Alright, this is the rectangle problem. So the length of a rectangle, I'm going to go ahead and draw a rectangle here, increases at a rate of 0.5 centimeters per second, and the width decreases at a rate of 0.5 centimeters per second. So let's go ahead and call this the length, and this one the width. We know that the rate that the length increases, so that's the derivative, rate is derivative. So dl dt is equal to 0.5 centimeters per second, and the rate of the width is decreasing, so that'd be a negative rate, so that is negative 0.5 centimeter per second. Alright, and now you're wondering, at the time when the length is 10 centimeters and the width is 7 centimeters, what's the rate of change of the area? Well, first we need a formula to describe the area of a rectangle. So you know the area of a rectangle is length times width. And if we derive this, so take the derivative of both sides of this equation, dA dt is equal to, now this you need to use the product rule with these two functions of t. So that means you take the derivative of the second one multiplied by the first one, so the length times dw dt plus w times dl dt. And now, remember, we're trying to find the rate of the area, which is dA dt. Then we just have to plug in what we know for L, dw dt, w, and dl dt. So you know the length is 10. The rate of the width is negative 0.5. Plus the width is 7. And the rate of the length is 0.5. And now we just simplify. So 10 times negative 1/2 is negative 5. Plus half of 7 is 3.5. Negative 5 plus 3.5, that's negative 1.5. What are we in centimeters? So square centimeters per second, which is answer B right here. So our answer is B. So that means the rate the area is changing, so the area is getting smaller at a rate of 1.5 centimeters squared per second. Sorry, square centimeters per second.